All right, today we're talking about something that is, believe it or not, an incredibly simple rule, but it can literally mean the difference between life and death in a serious emergency. We're talking about a quick calculation doctors use to save lives when the clock is ticking and every single second matters.
Okay, so I want you to picture this. You've got the controlled chaos of an emergency room, right? A patient with severe burns is rushed in. The medical team is on them in a flash, and their very first job, their most immediate challenge, is to figure out just how bad the damage is, and they have to do it fast. It's a total race against time.
So how do they actually do that? In the middle of all that pressure, with a life literally on the line, how does a doctor get an instant clear picture of the damage?
Well, in a moment like that, you can't exactly pull out some complicated piece of equipment or start running complex calculations. Whatever they use, it has to be fast, it has to be reliable, and it has to be simple enough for anyone on the team to use right then and there. Like we said, every second counts.
And the answer, the solution to this huge, high-pressure problem is this brilliantly simple method. It's called the rule of nines. So let's dive in and see what that's all about.
So, what exactly is it? Well, the rule of nines is basically a super quick, standardized way to estimate the percentage of someone's body that's been burned. It's called the total body surface area, or TBSA for short. And figuring that out is the absolute first, most critical step in treating a serious burn.
But you might be thinking, how can one simple rule apply to something as complicated as the human body? Well, that's the beautiful part. Let's break down how this incredibly clever system actually works.
Okay, so the big idea here is just genius because it's so simple. The rule basically carves up the adult body into different sections, and then it assigns each section a percentage that is, you guessed it, a multiple of 9.
So let's start from the top. Literally, we've got the head and the neck.
This whole area gets assigned a value of 9%. 9% of the total body surface area. That's our first number, nice and easy to remember.
All right, next up, let's look at the arms. What about one whole arm, from the shoulder all the way to the fingertips?
Yep, the pattern holds. Each arm also counts for 9%. So, pretty simple math, right? If both arms are burned, that's 18% right there.
Okay, let's move on down to the legs. Now here the number changes a little, but the logic is still there.
Each leg is valued at 18%. And what's 18? It's just 2 nines. See how clever that is? It's designed to be super easy to remember, even when things are getting intense. Okay, so let's put the whole puzzle together. We have the head and neck at 9%. Each arm is 9%. Each leg is 18%. Then you have the front of the torso, that's another 18%, and the back of the torso is also 18%. And then there's one last little bit, the perineum, which makes up that final 1%. And if you add all that up, it comes out to a nice, neat 100%.
Okay, so we've got the math down. It's a neat system. But why does this number matter so much? Why is it so incredibly important? What kind of life or death decisions are actually based on this 1%?
Well, here's the thing. That percentage is basically the key that unlocks everything that happens next. For starters, it dictates how much fluid the patient needs. See, bad burns make you lose a ton of fluid, and that TBSA number lets doctors calculate exactly how much IV fluid is needed to keep the person alive. It's a lifesaver. Second, it tells them if the patient needs to be sent to a special burn center. And third, it's like a universal language for medical professionals. A paramedic can call ahead and say, "We've got a 36% TBSA burn," and the hospital team knows instantly the severity of what's coming through their doors.
So when you boil it all down, the rule of nines isn't just some clever trick to help you remember numbers. It's a full-on diagnostic tool that's built for speed, built for the chaos of an emergency.
Really, this is the line that gets drilled into the head of every single medical student and paramedic. It's the whole system, right there, boiled down into one powerful thought. It's short, it's simple, and it absolutely saves lives.
And this system works incredibly well for adults. But that brings up a really interesting question, doesn't it? Think about it. A child's body is built differently than an adult's. Their head is way bigger in proportion to the rest of their body. So if this is the rule for adults, how in the world do you adjust it for kids? It's a great reminder that in medicine, you can't always have a one-size-fits-all solution.